Hello everybody, welcome to Data Platform Virtual Summit 2022. My name is Tomaž Kaštrun and I will be talking about addressing climate change with help of machine learning. A couple of words about myself. I've been MVP for the past 6 years. I have 20 years and even more experience with SQL Server development, BI, machine learning. I am a BI developer and data scientist, and I am coming from Slovenia. And since I'm mentioning that I'm coming from Slovenia, this part of the Europe, is definitely something that it will have a little bit effect on later on. Why am I actually saying that I'm coming from Slovenia is that Europe has, in this summer of 2022, had a extensive heat waves and drought that wasn't, the history says it's, the severest, the extremist drought in the past 500 years. So the heat is actually on. And if we look at the statistics of the past 20 years, there's been more than 7,000 major disaster events, which claimed about 1 million lives, but affected approximately half of the world population, and cost approximately $3 trillion losses in global economy. So, the heat is on, which actually means that, that climate change is something that is fairly, present, that we should be more aware of it. And let alone in 2019, and I believe also in 2020 alone, we recorded the highest CO2 emissions in the human history. So the question is actually, where can machine learning and artificial intelligence and cognitive vision and computer vision, where can these technologies help? So let's just get a step back and see, what really is on the table. So if we look at the organizations, a lot of the organizations are struggling nowadays with how to actually adapt to the climate changes and what actions should they prioritize. So this is taken from the Capgemini research that was done 2 years ago in June to August of 2020, and they've looked roughly around 400 companies. And on the matrix, you can see that there are 4 quadrants, and on the x-axis, you can see that the company is AI capable and has the means and knowledge to execute this, and on the y-axis, they have sort of the vision what to do in case of that. So they've literally looked at the companies and seen that majority of the companies have no AI knowledge and don't know how to execute that, nor they have aligned organizational vision that would be aligned with the climate vision and strategy. So they essentially lack knowledge and also the vision for the future of their organization. So, and then you have 13% of the companies that are climate AI champions, which means that they have the means and the knowledge, and also they've aligned the organizational vision to tackle the climate change or the vision. So, coming to this conclusion, there is still a lot of companies, let's say almost half, that have no idea what to do. There are some that, are aware of the power of machine learning and artificial intelligence, and there are around 20% also that have adapted to the climate vision and strategy, but like machine learning and artificial intelligence knowledge. So, in a sense, there is still a lot field and a lot of open areas where all these organizations are capable of sort of, going in that direction in terms of, adapting to that. So, and I've also seen, since I'm coming from Slovenia, I've also seen a couple of major Slovenian companies that have actually also had created so-called sustainable departments and departments tackling with the green transition and stuff like that. So these are all good news, which means that companies are aware of that and they are sort of, getting people on board that are facilitating those fields, getting people on board and sort of, doing on a daily tasks what they should do in terms of adapting or in terms of transformation or in terms of any type of activity that they could do that they would sort of help this kind of vision. So just to give you a rough idea where sort of based on this research the companies literally are. And those companies that are lacking literally either one side or the other side, the question is what to do. So there is an actionable plan available, and also European Union, since I'm coming from this part of the world, has also prepared an actionable plan for the all the EU countries, what to do. So one thing that we can do is sort of do anything regarding the mitigation, and this can be affected by electricity system, transportation, building, cities, industry, farms, forests, or any type of carbon dioxide removal. The second one, the second pillar is adaptation. So what can we do in terms of adapting to climate change? Where can we do any type of prediction? What's going to happen? How let's say how many participation for a particular country there would be to severe drought or any forest fires and stuff like that. So this is one thing. So the other thing would be impact on society. So this is something that we can start doing now every day. Instead of traveling with a car, you can start traveling with a bicycle, learning about environmental changes and environmental behavior in schools and stuff like that. So this is all basically packed in here. And then there is also solar geoengineering that is also capable of sort of getting much more out of the sun energy, and what essentially can we do here in order to adapt to that. And the third pillar is actions and tools without individuals acting upon, or as a society acting upon, and also without education, without plan and vision, as we've seen in the previous slide, and of course also finance. There would be no any actionable plan created. So in order to have all the actionable plan prepared, organizations and also society or individuals would sort of have to have all three pillars getting ready. In a sense, adaptation is something that we as human beings, we as individuals will have to be prepared and have to sort of get a little bit out of the comfortable zone, in order to sort of change our daily routine. So this is also something to consider. So agenda for today is we will sort of see approaches for tackling climate change, mitigating and reducing the CO2 emission, and adapting to change. So these three sections will essentially be tackled, and each of these section or segments will have a proposed machine learning, Microsoft Azure architecture for machine learning. So we will see, how can we tackle climate change, and once we sort of explore those areas, we will also see, what in sense of machine learning algorithms we can use and how we can sort of transform it into Microsoft Azure architecture for the sake of, getting faster results from those ideas, concepts, algorithms, and essentially getting the results. So approaches for tackling climate change. Tackling issues are essentially predicting the rare events. So this is something that all machine learning algorithms are struggling with because they're rare. It's hard to predict when they're going to happen. The rarer they are, the harder it is to predict. But there are, many of those rare events that in the past 2 years, probably 3 years, are becoming relatively frequent. The second one would be scheduling the renewables. So this is something that, a lot of countries are already doing, if not, half of the world. So in terms of electricity and gas, how we can sort of use the energy more efficiently. The third one would be accelerating forestation, since there are a lot of fires and there's a lot of logging and deforestation. There should be also the counterpart activities in order to sort of have all these trees where there are logged should be also forested. And the fourth one would be image analysis using also neural networks. So this is something that essentially is not an issue, but we will see it sort of as what we essentially can do with it. So predicting rare events. So what is essentially a rare event? A rare event is, it can be a tsunami, it can be a volcano eruption, it can be any type of hurricane, it can be a flooding or a landslide, or it can be a forest fire, it can be a drought, as I said at the beginning. Europe has been hit by the severe drought this year, the one that hasn't been seen for the past 500 years. So this essentially is a rare event, so it sort of happens, relatively rare. It can be something, it doesn't have to be this, but it can be anything that, it should not happen, based on your definition in a, amount of time. So all of those are essentially rare events, but in terms for the climate change, we can use any of those. Those are essentially, one can be essentially the results of the climate change. The other one is, for instance, volcano eruption does not have to do anything with climate change, but those are those rare events. So there are a couple of algorithms that we can use. For instance, decision forest, numerical simulations, GBM, then also boosted algorithms for better, let's say, recall precision balance. These are especially important when it comes to a particular events like earthquakes or landslides. And then there is corresponding short-term predictions for chaotic systems and multi-fidelity stochastic computational models, which is sort of a combination of high-fidelity Monte Carlo simulations and low-fidelity Markov chains. So essentially, we are building, sequence of events using simulations and Markov chains. So these are a couple of those algorithms that can be used in terms of getting, the better results when it comes to machine learning or artificial intelligence results. So essentially, we've seen what the rare event is and how can we tackle giving particular machine learning algorithms. The second one is planning the renewables. So scheduling and planning the renewables is something that we will have to do more frequently in the future years. So, for example, I'll give you, there's been in September of this year, 2022, California in the United States has been hit yet again with a huge heat wave. And because of all this heat going on, there has been a lot of air conditioning running, etc., etc. And all those energy consumption sort of represent a huge stress on the electrical system. So they have been sending out, for instance, short messages on end users' mobile phones saying, you know, if there is something that you don't literally need, maybe you should turn it off. So this is, you know, sort of going into this scheduling and planning. So, you know, if you don't need something, you know, sort of unplug it and give it back to the grid. So this is something that with the more extreme heat and climate change, we will essentially be forced to do stuff like that. So, and what is then scheduling and planning? So we can, for instance, have a short and medium term forecast of consumption, meaning that based on the previous years or based on, you know, when there is a heat wave, we can sort of predict what will be the energy consumption, and based on those we can start, you know, acting upon, saying we will shut down this, we will shut down that, so that the electricity grid can withstand all the pressure. Then there is a decision-focused forecasting, even reinforcement learning to sort of accommodate system balancing in the electricity grid. Then there is also enabling centralized optimization, let's say for solar or for the green production, so the solar and the wind. And we can use, for instance, any enforced deep learning with the control theory. Then there is the wind turbines optimization, peak shaving for the electricity. So there is quite a lot of different machine learning optimization or optimization algorithms that can help you prevent, you know, consuming too much energy, giving the energy back to the grid, or sort of omitting those peaks in terms of the energy. So what is a peak when it comes to energy? You know, usually we get up in the morning, and between 6 in the morning and 8 in the morning, you know, there is a high consumption of the electricity because, you know, everybody's running to get a kettle, to get a tea, to get a coffee, and you can see the consumption going, you know, rising. And then it sort of decreases because people are going to the jobs or on the fields doing, you know, what they do. And then in the evening, roughly around 4 p.m. to, let's say, 7, 8 p.m., again, there is another spike in the energy consumption. So these are all the peaks that we can, you know, based on smarter planning and playing the renewables, we can sort of optimize. And when I say renewable, we can say, okay, you know, if there is a peak and there is, I have a solar or a wind production at my house, essentially more solar than wind, you know, I can sort of compensate and return from my solar panel back to the grid and sort of, you know, diminishing these peaks. So this is something that we all can do. The third one is accelerating forestation. Again, especially in the Amazon or, you know, parts of the world where there is a high density of forests, or Northern America, there are, you know, with all this forest, there also comes, for instance, illegal logging and stuff like that. So we can start using any type of machine learning algorithms, sort of, for instance, getting satellite images of the land to see if there is any, for instance, illegal or selective logging. We can also use remote sensing for deforestation. Essentially, it is the same. One happens naturally, the other one happens by people. There are also open forest projects that sort of gives you all the data, but we can also get the data from, let's say, Sentinel, Landsat, and you can use CNN, which means the convolutional neural network, to sort of see if there are any deforestation, illegal or legal, natural, or if there is any land abandonment. Especially, I will speak about my country, Slovenia. There has been in the past 20 years quite a lot of land abandoned, which means that it is not economically anymore to sort of grow crops, and then the farmers are sort of abandoning the lands, or the lands is being converted into any type of facility, or just simply being abandoned. And we all know that the land essentially is something that we cannot expand unless we are in the Netherlands or some other parts of the world. But essentially, we have the land. The land is actually finite. It's not infinite. It's finite. And if we abandon it, there should be also the ways to see what used to be there, if it's abandoned, etc., etc. So we can help tackling these three issues with, for instance, with machine learning. And then there is also mapping plantations and any type of forest. We can use different algorithms. Again, remote sensing datasets are available if you are, interested in that. There has been quite a lot of canopy height analysis done, and also models created. So canopy, the tree has a canopy, especially in the cities, and they've been analyzing, the reduction of the heat in the city, trying to see, how green is a particular city, what can we do to sort of even the temperature in the city using analysis like that. And then there is also, categorization of light detection. There is, a couple of those algorithms that you can use to sort of detect different lights, throughput in the range of the lights. You can define, this is, if the light goes through in this range, it means there is, for instance, type of the nutrition missing. If it goes in this range, it could mean that there is a water present and stuff like that. So quite a lot of stuff available for that. And the last one is also there's also capability of using numeric hydroclimate models, which essentially is more physical model using CCAN, for instance. And again, much more, but just to give you a rough idea. And the last one is actually image analysis that I've been, sort of pointing now for a couple of times. So-called remote sensing, or if you take your mobile phone, for instance, the newer mobile phones have now so-called LiDAR, which is essentially used for this remote sensing. So, what does this mean? If we take, for instance, any type of aerial or satellite images or aerial images, we can use, based on this LiDAR technology, we can extract different colors, extract different layers of the water presence, humidity presence, different nutrition presence. So based on that, we can then analyze, the image, and different colors or different sections on the spectrum can give us additional information. But again, we can also use that for object detection or any type of semantic segmentation, spatiotemporal forecasting, for instance, something that is commonly used, and also super resolution or image pixelization is also something that can be used for. And also those pictures that you see on the slide are something that is everything literally taken from the real case scenarios. On the right hand side is actually how, for instance, a Tesla self-driving car sees all the objects and could sort of quite fast determine what a particular object is, and everything is done using this so-called LiDAR technology. Okay, so now that I've mentioned a couple of those algorithms, what do we essentially need for that? So again, going back, if you're an organization and you want to sort of adapt to the climate vision and strategy, and also get and gain some knowledge, so what essentially would this company also need? As I said, everything will be based on the Microsoft Azure technologies. So in this case, you would definitely need to have the knowledge background. You would need particular roles like data analyst, data engineer, machine learning engineers, data scientists, and then you would choose the storage where you would gather all the data, and then essentially the technology, whether you want to use the data streaming, just doing the predictions, or if you want to do only the reports and visualization. So I'll just give you a couple of out-of-the-box Microsoft proposed architectures. So for instance, just big data analytics, this is fairly out of the box by default. Microsoft would say, okay, take machine learning services and use Azure Synapse, get the data from Azure Data Lake Storage. How you would get the data in, it's really up to you, whether you are using IoT stream data, logs, events, photos, or business applications. You can use, if it's a cold path, you can use Azure Data Factory. If it's a hot path, you can use a variety of different stream ingestion tools like Kafka or Flink, IoT Hub, Event Hub. Essentially, all the data would come into the Azure Data Lake Storage using Synapse, Azure ML, or Databricks. You would do all the magic in terms of the predictions there, and then you can do the visualization in different tools. Yet again, if you're a fan of Databricks, you can go, and see how the data would be ingested, using Event Hubs or Azure Data Factory as seen on the previous slide. But then you could use different Azure Data Lake Storage, how you want to, operationalize your data, whether it's a raw data like bronze, or curated data like silver and then gold, which is sort of added value of the data. And again, you can use Databricks, you can use Synapse, just a slightly different view of this architecture. But then again, if you're using quite a lot of simulations, like I've showed you, Monte Carlo and Markov chain for the rare events, you can also use Azure Kubernetes services if you're using quite a lot of computations or parallel computations, which essentially can be straightforward numerical formulas. Of course, you could use that as well. Okay, the second segment, or the second group of that we need to address is mitigating and reducing the CO2 emissions. There's quite a lot of fields in our daily life that we need, or that we could tackle, and the list could be, far longer than this. I've decided to just, sort of take a peek into farms and agriculture, transportation, buildings, and cities. So farms and agriculture, again, we can use LiDAR sensoring and remote sensoring to find overheating, in the soil, to get the soil structure and to have much better management of the soil. Again, this would be useful, if you have quite a huge area and land of crops. Definitely something like that. You can also use any type of optimization algorithm to have the precise agriculture created. So if you have the soil structure, if you have the weather data, if you have, any type of data on the culture, you can sort of start, optimizing a very much precision agriculture, as it is called. Which part of your land is perfect for which crop at a given year or at the given season. There's also very famous agriculture disease detection, or if the crop is invaluable, which means that you can remove it faster and do something else with this patch of land or something. So again, this is helping very, very much in terms of the farms or agriculture. You can also use neural networks for better water and crop management using, for instance, IoT. And I've seen quite a lot of farms that are, highly technologically advanced using all this IoT, getting much better results than the farms not using that. And you can also, for instance, crop yield predictions, again using any type of aerial imagery, whether it's drone, whether it's satellite image. Again, with that you can then improve the moisture, the fertilization, and the natural nutritional level, meaning that particular, as I said before, particular patch of land might be good for this crop but not for that crop, or this year this patch of land is not good for any of the crop except for this particular crop. So again, you can play with all this data if the data is available for you to get much better result. Transportation is something that is very, very debatable. I don't really want to go too deep into that, but definitely I can say a couple of machine learning algorithms that are very useful for that. One would be graph theory, trying to determine and find the best ways when we are in urban areas. Also, theory-based residual neural networks are good for finding better routes. Again, spatio-temporal topic model or models. Discovering latent activity patterns, again, something worth mentioning, but then you have to sort of have this present in order to get the data, and then you can start with analysis of that. And you can also model transport demands. You can optimize freight routing and bundling, which a lot of companies are doing, and you can also improve electrical vehicles and low carbon transportation. So, a lot of countries are doing that, but then just saying and stating, what also can be done. In terms of the buildings and cities, there is, especially in Europe, there are, a couple of those, let's say, algorithms available, or people that I've seen are using that. But then again, in rural areas of the world, a lot of this is being used. So let's say I am definitely living on a area where, for instance, there is a lot of earthquakes. So if you would have the capability of, let's say, drone capturing the images of the houses and predict when the house is going to be, whether the house would be resistant to a particular earthquake, then you can sort of use that technology. And vice versa, if there is the very old house, and you can say if an earthquake would hit at this level, this house would collapse. So this is something that you can use with the drone technology. Again, the same goes with floods, or any other type of identification of foundations in terms of constructing or buildings. And you can also use, for instance, finding illegal wastes, dumps of wastes. You can also capture the images of that, train the model, and see with, let's say, with the images, whether it's a drone or satellite images, try to find, if there are any illegal dumps of trash or, any type of toxic waste. And then again, as I said, urban tree canopy is very, very famous, or not commonly used, but famous. And also, using the remote sensing, you can see what will happen with dwelling cities in terms of the extreme drought or extreme flooding, which again we've seen, for instance, in Pakistan, in end of August 2022, dumps of water, just, years of water, has been, flooding 1/3 of the, country. You can also essentially, based on analysis of the soil, analysis of cities, sort of try to simulate or predict what would have happened in case of drought, fires, or flood. So again, this is very popular technologies, methods in order to sort of improve better buildings or cities with the use of different technologies and with the use of different algorithms. Again, what do we need? Again, the same as previously, technology to capture all the data, people, especially machine learning and data scientists, data analysts, data engineers, to sort of, put all the components together, storage, and then also the technology. So in this case, I've decided to go with bed scoring with the use of Spark and Databricks. So let's say that you are ingesting images that we've been talking about, drones and stuff like that. So sort of you ingest the data, and then you do the feature engineering, trying to find the best features, the relevant features. You train the models, you score the models, and you get the results back. Again, everything based on the Apache Spark technology using only Databricks. Again, one of the proposed architecture. The other one can be image classification. Let's say that we are taking images with the drones of our city, and we sort of try to flag this is good, this is bad. Let's say this building would withstand that earthquake, that building would not withstand the earthquake. And based on that, you can sort of do the image classification, for instance. Again, using computer vision API, and storing the data into Cosmos DB, and again using, let's say, Azure Functions, and that's it. And then there is another use case. This one is of another use case, how to use the contactless IoT interfaces with Azure Edge. You have a bunch of endpoints, the Edge board, store the data into the cloud, and get all the machine learning done with Databricks using the CNN algorithms. Again, as I said, image classification with CNN, but in this case, you can, instead of going with Databricks, you can use Azure Kubernetes services. And again, the proposed architecture would essentially look, say, something like that. If you're coming from utility sector, this might be also an interesting architecture for you. So let's say that you would be interested in forecasting energy and power demand. Again, just to give you a brief overview, you can use, again, Azure Kubernetes services, might also be Databricks, but then again, as seen on this photo, you would use Azure ML services with the SDK and beautiful GUI, and you can do the training and feature selection essentially with that. And then once you have this, you register model, you deploy the model, and you go with inference of the new data. Okay, the last part is a little bit more, we need to talk also about society and people adapting. So how do we gonna go adapt to the changes? European Union said that had this deal called European Green Deal, that by the year of 2050, Europe would be neutral, so carbon dioxide neutral, meaning that by in the next 30 years we would get rid of, let's say, all the diesel automobiles, heavy industry, etc., etc. Essentially, why is this important? Because I have to ask myself, what can I do, or what can we do today? We have to combat the negative impact on the climate. We need to start educating people, about, how critical actually the climate changes are, and explain, how artificial intelligence, machine learning can really make a difference. We have to establish, some technological boundaries and foundations to help organizations. And we have to have those use cases that can be prepared and can be scaled, to, fast to majority of organization. And of course, we need to start collaborating and start discussing about this climate change. The other thing we need to also discuss is the human response. So this is again taken from this report by Capgemini, and I found this extremely useful. How do we humans actually interact and behave in case of humanitarian crisis? On the left-hand side, you would see that your typical, something goes wrong. There is a humanitarian crisis, whether it's a drought, flood, fire, avalanche, it doesn't really matter. And you can see that, the shock has happened, and it takes, some amount of time for the first response to begin. And we all know that in case of crisis like this, we usually start gathering, we need to assess what people would need. We need to start planning, prioritizing. We need to, start getting funds, etc., etc. So all this actually takes time. Before the first, let's say, aid arrives to the location where the crisis has happened, can, usually take a week, hopefully only half of the day, but, it tends to sort of progress toward, longer than, let's say, half of the day. And before the humanitarian aid is provided, usually the crisis sort of, start declining. But then again, you would have people, needing medical treatment, food, water, and stuff like that. So on the right-hand side, you can see that based on the, tracking the data, the weather, the rare events, the drought, the fire, etc., we can start making forecasting models or decision-making models, regardless of type of the data or type of the event, and we can start establishing different plans, so pre-establish different plans in case of this, in case of that, in case of that. And we can also pre-arrange, in this case, financing, but it can also be anything else. And before the shock actually, before the the crisis, the event actually happens, we can start gathering the early warnings. So we can say, okay, there is a high chance or high possibility that in this country this will happen. And we can start just, getting things together, getting alert and stuff like that. And based on that, we can sort of flatten the curve for this humanitarian crisis, because we are sort of, seeing what's going to happen, especially in the rare events, and we are having sort of model constantly being trained, constantly seeing, okay, this might happen, it's going to happen, 100% sure, and, start gathering all the data together. This is, again, a real case scenario that happened in case of a huge Bangladesh flooding 2 years ago. What has happened was they have been sort of developing this prediction based on the water flow. So they've been observing the water flow for quite a long time, and they started predicting the water flow for, let's say, 5 days ahead. Every day you sort of predict for 5 days ahead, for 5 days ahead, for 5 days ahead. And you can see that the dashed dark blue and the full line light blue are sort of very on par. So what they've been doing is they've been reading this data and sort of predicting what will happen in case of a crisis. And you can see that orange line is where sort of the danger would happen, and where the maroon is actually where we need to start making any action. So essentially what they did was, based on this model, they've actually predicted that the water flow will rise. So you can see that July 13th, 14th, 15th, it will go beyond where they would need to take an action. Based on that, they knew that, it's gonna rise, it's gonna rise, it's gonna rise, and they could start, getting the help, in case of this crisis, already have the aid in case, whether it's money, whether it's medical equipment, stuff like that, having had this already prepared, and also finances. So when the water actually went through this maroon line, so this was July 14th, 15th, they could sort of release the cash, transfer the cash directly to the local peoples, that they could either have the means to sort of transport the goods to different location, or to move to different location until the water flow sort of gets below the critical point. So again, this was something that, based on the model and the data gathered, and again, is only water flow observations and the weather data, they've managed to sort of have the cash, financial transfer, medical transfer prepared for them in advance. Again, something worth mentioning, the architecture, again, in this case, can be Databricks with Azure Machine Learning Services, or any of those previously mentioned. And what would be the impact on society and humans? Of course, we need to also get prepared for that. So, we've seen, at least in Europe this summer of 2022, that drought can sort of impact very severely the agriculture, which means that, instead of, growing the agriculture literally at your doorstep, you have to import the agriculture from different parts of the world, meaning that, the price would rise, etc., etc. So this is something that we need to be prepared for. Again, for countries, for people living close to the sea, what would be the sea level, if the sea level rises, what would be the impact and how this would actually threaten cities around the world. We've known that, for instance, the capital of Indonesia has had issues with sea level for the past 20 years, drastically. So, and the lives and society and human beings will definitely be marked for that. And again, their lives will have to be changed. And there are also, how to lower the green gas emissions with zero or less side effects, how to abandon the usage of fossil fuels and get some other, we say, green energy or any other natural resources, etc., etc. So all these will definitely have an impact on society, and it's just how we're gonna sort of adapt to these actions. In my last slide, so the key takeaways for today is a lot of organizations, what I've seen, at least in this part of the Europe, are still not aligned with the climate vision. If they lack knowledge, and with this session I've also introduced a couple of ways how to tackle, how to measure, how to get data. There are also many different industries and fields that still don't use but could use machine learning, and I strongly support that they start using that they get on board. Computers have become super cheap and can be scaled, and just to sort of give them the services that they would need. And again, we can sort of have a lot of daily operations, data-driven, automated, and can be essentially superseded by machine learning algorithms, or could have machine learning algorithms attached to these actions. And again, remember, every human being, you, me, we all can make a change on a daily basis, of course, by saying, today I will not do this, I will do that, and if we all repeat this every day, we will definitely see a positive trend in terms of the change. And the last one, definitely the community is the strongest. If you don't know, ask. If I don't know, I usually ask. So, getting our heads together, getting people together is definitely helpful. Thanks again, especially special thanks to Microsoft for supporting Data Platform Geeks and SQL Server Geeks and all the community initiatives. Thank you very much. Feel free to get in contact and follow us on Twitter, and have a great remaining of the event. Thank you very much.